Okay, so today's video is a very basic completing the square, and I am going to be showing you a geometric idea. We'll get into algebraic a little bit later, but one of the things I want to do, we're going to start by looking at y equals x squared plus 8x plus 10. And the goal here is to rewrite as in vertex form. So that's where we're going with this. But let's refresh ourselves a little bit as to what algebra tiles are. So algebra tiles, we've got tiles for x squared, and they are a square with dimensions of x by x. And you can see these off to the right, dimensions x by x. An x tile is a rectangle with dimensions x by 1, and then a unit tile is a square with dimensions 1 by 1. And this is important because we're going to use this concept for this completing the square idea. So let's start by taking a look at the x squared plus 8x. Some books, some instructions will deal with this 10, but what I'm going to do is I'm going to completely ignore this plus 10, and I'm going to set it off to the side. And I'm just going to look at the x squared plus 8x. And what I want to do, and the reasons will become a little bit obvious later, is I'm going to take my x squared and my 8x tiles. Get me patient with me while I draw these out. 1, 2, 3, 4, 5, 6, 7, 8. And I want to try to build a square. So when I look at this, here's my x squared. Well, I've got 8 tiles, so that should mean that I could put 4 on each side, and I will have something vaguely square-ish. 3, 4, and 1, 2, 3, 4. If I were to fill in this corner, I would have a square. This square would be x plus 4 by x plus 4. But the corner's not filled in. Well, what do I need to fill it in? Well, this is a 4 by 4 square, so I need 16 unit tiles. Now, some teachers will tell you, well, take the 10 that you've got and plug them in there, and then you're missing 6, so you show. Here's what I don't like about that. That's fine until you have negatives or fractions, and it gets really complicated. So I like to just say, let's pretend I don't have any unit tiles. And so in order to make this an x plus 4 square, I had to add 16 tiles. But I didn't have 16 tiles. So in order to keep it in balance, I need to subtract 16 tiles. These cancel each other out. I've got plus 16 to make the square. I've got the minus 16, and they cancel each other out. And so what this square represents is x plus 4 squared minus 16. The x plus 4 squared has 16 tiles in it, but I've got a minus 16 on the outside. So this x plus 4 squared, whoops, sorry. This x plus 4 squared minus 16 is equivalent to x squared plus 8. Now, I'm just going to bring my plus 10 back in, which I just ignored all this time, even though it was sitting off to the side. And I know that this equation can be rewritten as y equals x plus 4 squared minus 6. And since this is in vertex form, I now know that the vertex will be at negative 4 comma negative 6. Okay. Let's do one more example. Y equals x squared plus 6x minus 7. Why don't you go ahead and pause the video and write this in vertex form? Okay. So what I am again going to do is I'm going to take that -7 and I'm going to shove it off to the side and I'm going to ignore it for now. And I'm going to make a square out of the x squared plus 6x. By the way, as you get better at this, you don't have to always draw the squares, but to begin with, sometimes it's helpful to visualize. So what have I got here? I've got a square that is x plus 3 by x plus 3. In order to make it a square, I had to add 9 unit tiles. But because I added 9 unit tiles, I have to subtract 9 unit tiles to keep it in balance. And then I will bring my -7 back, giving me the equation y equals x plus 3 squared minus 16, which means that this parabola has a vertex at -3 comma -16. Boom. Done. We'll come back a little bit later with some videos about how to do this if you have a odd number of x's, so it's harder to divide them up, and what to do if I've got a stretch factor, my a value larger than 1, which right now I don't. Okay, thanks for watching.